students, in this video we will be taking a look at real-life problems, word problems, that will apply what we have learned in Chapter 2. Now, there will be 3 videos that go over word problems from Chapter 2. You're probably starting to see now how Mr. Earhart does things. I teach you the fundamentals and all of the math that you need to know. Then we go back at the end of the chapter and we apply it to word problems. By doing it this way, it definitely makes for a very tough or difficult 2 or 3 days. But it's also good to get all the fundamentals out of the way before we apply them to word problems. Your heading today is Chapter 2, Word Problems Part 1. Please copy that down. Chapter 2, Word Problems Part 1, and be sure and include today's date. I believe that's always a smart thing to do. So, Chapter 2, Word Problems Part 1. Most of the word problems that we will be looking at in class today, and by the way, we're looking at 2 problems in your notes. This will be a pretty short video. I want most of your focus to be on your homework. But most of the problems we're going to look at in class today, 2 problems, and in your homework, deal with slope and writing equations. Some are a little challenging, but for the most part they are not super difficult, okay? Let's get started with the first problem. Now, I would encourage you to not copy the problem down. I think it takes way too much time to copy this problem down in your notes. Instead, I would just put page 73, example number 3. Page 73, example number 3, okay? And here we go. In 1980, 3.5% of the doctorates in engineering were awarded to women. So I'm going to put 1980. I'm just kind of taking notes, okay? Just like you do in class, I'm taking notes from the word problem. So in 1980, 3.5% of all the doctorates were awarded to females. By 1990, it had risen to 8.5%. Find the average rate of change in the percent of engineering doctorates earned by women from 1990 or from 1980 to 1990. Now, I want to point out to you that this comment right here is exactly right. Slope as a rate of change. Your slope is basically a rate of change. I mean, when you apply it to word problems, that's what it is. It's a rate of change. For example, please listen to me carefully. If I told you you have $50 in your savings account and you're going to earn $100 a week, you could write a model like this. $100 times every week plus 50. Now, because look, think about it. You started off with how much money? $50, and then every week you get 100. So you multiply each week by 100. Well, this is your slope right here. I mean, y is by itself. So the coefficient of your variable right here would be your slope, and it's not this slope right here. Nothing more than just a rate. What's the rate, Mr. Earhart? Are you kidding? $100 per week. That's a rate. So slope can be used as a rate of change. And your slope here is $100 per week. So when they ask us to find the rate of change, they're just kind of helping us get used to finding rates of change. Sometimes those can be looked at as slopes, okay? Now, let's find the average rate of change in the percent of engineering doctorates earned by women from 1980 to 1990. Now, here's what they're saying. They want us to find the percent of women per year. That's what they want us to do. That's the rate they want us to find. The increase in the percent of women per year. So here we go. We started off with 3.5%. We ended with 8.5. What kind of increase was that? Well, let's subtract those 2 and let's find out. You get a 5% increase. So I have 5% per, and per can also be looked at as a division line. So I have a 5% increase from 1980 to 1990 per every how many years? 10 years from 1980 to 1990, okay? Now, if I take 5 divided by 10, now you might say, Mr. Earhart, it's a percentage. You should use 0.05. Normally, you're right, but it's saying they want the rate of change in the percent of engineering doctorates earned by women. So they're already saying it's in percentage form, okay? So we have 5% every 10 years. So 5 divided by 10 is, we have a half of a percent increase per year. That should make sense, guys. 5 divided by 10 is a half a percent, or if you put 0.5, that's fine. Okay? So 5 divided by 10 is a half a percent increase per year. And that's it. That's all they want us to do, is find the average rate of change in the percent of engineering doctorates earned by women from 1980 to 1990. Okay? Pretty simple. Alright, let's try another problem. In your notes, write down page 80, example number 3. Page 80, example number 3. You are the manager of a convenience store. Based on retail prices, your markup rate on gas is 8.3%, and your average markup rate on food and other store items is 20%. Write a model that shows the amounts of gasoline and food you would need to sell during a week to obtain a total markup of $1,000. Now, this really is not that hard, okay? Your gasoline is marked up 8.3%. So I'm going to take all of my gasoline, I'm going to multiply it by 8.3%. That should make sense, guys. Your markup rate on gasoline, that means how much do you increase the price to make a profit. You mark it up by 8.3%. So all of the gas that you sell gets multiplied by 8.3% plus all of your food items and other items is marked up 20%. So we're going to multiply all of those items by 20%. So you take all of your gas, multiply it by 8.3%, take all of your food items, multiply them by 20%, and you want to get $1,000. So that's your model. You're basically done, except I don't want percent signs in your equations. So instead of putting 8.3%, we're going to put 0.083 G plus 0.20F equals 100, or 1,000, excuse me. Now, you might have used different letters than G and F, that's fine. But do you remember how to convert percentages to decimals? You move the decimal 2 places to the left, okay? And that's why I got these decimals down here. So it's that easy, guys. Write a model. Here's your model right here. And that model shows the amount of gasoline and food you could sell during a week to obtain this right here, okay? So if you know you've sold, like, I don't know, 100 gallons of gas, you could put that in for G and then solve the equation for F, and then you would know how many food items, or how much food items you need to sell to get your $1,000 profit. So a model like this is really helpful. Okay, so that's all we're doing today. Pretty simple. It's not meant to be a long note-taking lesson. Get to work on your homework, please. If you have any questions, don't hesitate to call